All right, welcome everyone to the Azure Special Interest Group. It is August 9th, 2017, and I am pleased to see you here. If you would like to see the meeting minutes for this meeting, they are available at bit.ly/sig-azure. Probably should make that an aka.ms URL at some point, because that's sort of what we do, but for now, it's still bit.ly/sig-azure. Today we have a very full agenda. I'll try and get through it as fast as possible, but we're going to start with a fantastic demo from Jack Francis from Microsoft, who's going to be showing us some large cluster action. So without further ado, Jack, you got it.
Hey, Jace.
Yes.
Hey, everyone in SIG Azure. So I'm going to share my screen and give a brief demonstration of how we have addressed some challenges we faced in building large clusters at Azure. So some of the background is that large Kubernetes clusters generate a ton of traffic in between master and agent nodes. A ton, I guess, is up to the interpretation of the beholder, but for the purposes of the API that serves all of these underlying infrastructure resource requests, it has determined that that's a ton of traffic over a certain amount of nodes. I'm going to use 100 as a kind of simple demarcation point for, below that, we're not considering that a large cluster. It's actually not quite that simple. But if you're building 100 node, 200 node, 300 node clusters, what you're going to notice is that your Kubernetes clusters are going to generate a lot of traffic just reconciling various resource bits, and when new infrastructure needs to be scaffolded, then those requests are dispatched to the Azure API. And at a certain point, the Azure API thinks it might be being DOSed, and so it will respond with certain types of throttling 429 responses that will de-optimize your cluster and under certain conditions actually make it unusable. So what we did to address that is we introduced into the cloud provider code itself in upstream Kubernetes some backoff responses to these API requests, and also rate limiting. And so these are all configurable opt-in options. By default, they're disabled. So it's backwards compatible for the pre-existing cloud provider implementation. With when we delivered this feature, it's an opt-in flag. And additionally, there's the vector in which we sort of support this usage is our ACS Engine project inside Azure. So I suspect a few of you guys know about ACS Engine, but if you don't, ACS Engine is the kind of underlying SDK/CLI for, what's the best way to put it? In a way, it's an SDK for standard SLA supported API calls between the sort of high level APIs and low level libraries that actually are responsible for dispatching requests in an Azure compatible way. On another sense, it's actually, you can compile it and run it as a CLI to generate your own templates and create custom cluster configurations. So the latter thing that I just described is kind of how we wanted to address customers who are building large clusters and who wanted this back off and rate limit feature. So I'm going to go through, I'm going to open it up to general questions just for a second, because I said a lot really quickly. Does anybody have any concerns? Let me see if I can.
Just which release upstream have you pushed those limiting feature?
That is a great question. So it's in 1.6.6. So actually, I've got in my screen share here the PR, the original PR for this. And I actually don't know if there's any decoration commentary here. It looks like it's not in the comments, but this original PR went out with 1.6.6. Is that right, Jace? Am I getting that right?
That is correct.
Cool. Any other questions? Cool. So a quick demo of ACS Engine, which is, again, what I'm going to use as the kind of user vector to build the cluster configuration that includes these features and give myself a template that I can then dispatch to Azure API for building a large cluster. So I'm going to go over here to my VS Code window and look at we call an API model. This is really, in simple terms, just a representation in according to an Azure specific interface of how your cluster will be configured for ACS. So the important things
Hey, Jack.
are, yes, Jason.
Can you would you please embiggen the font?
Embigganize. Yeah, is that as simple as this? All right. So the big version of the font, which should be readable now. So the key points are, as was asked, this is the Kubernetes version that we want to specify. In fact, ACS Engine has a new way of doing this, which looks like this. I'm just going to go into the weeds just because we're all engineers. So either one of those, depending on which version of ACS Engine you're using, specifies the Kubernetes version channel that you want to be on, because these features that it's going to pass along are only enabled in that and above. So the key is this Boolean cloud provider backoff feature. If this is set to true, then that engages all of the cloud provider backoff wildcard knobs. So there's a lot of description in the docs here. We have, when we merged all this usage into ACS Engine, if you go to docs and Kubernetes large clusters.markdown, you'll see a more persistent description of this. I'm still going to walk through it, but for those who conclude that I'm going too fast at the end of this discussion, you can go to this document, and it has a really good, actually it doesn't have the, anyway, this is a good summary of what I'm going to describe right now. So basically, this engages the backoff feature. This tells the backoff logic how many times until abort. This introduces some per retry interval jitter. This is the initial duration in seconds. And this is the exponent that the algorithm uses to determine successive retry attempts. So normal, if you we're thinking like vanilla exponential backoff to the power of 2 would be that. And then if you wanted to really say, try once, and I really trust that if it doesn't succeed, I don't want to try for a long time, you can do something like that. And then the second feature I mentioned is a rate limiting feature. So if you set this to true in your API model, you can, this is going to be inline for several specific API type requests. So basically what we've determined the kinds of API requests that are most likely to be side effects of normal cluster behavior that in a large cluster configuration result in a lot of traffic. So these go through this rate, when you opt into this feature, all of these requests go through this rate limiting enforcement logic. So QPS is what it sounds like, and bucket is basically a buffer. So if your QPS is set to 3 and you send a 4th request and a 5th request, etc., it will fill that buffer until it runs out of bucket units, after which point those requests will simply be dropped. So that's how that works. And again, if you read the PR, the code is actually pretty clear. These are not novel implementations. They're copied from, or reused, I should say, from existing well-used backoff and rate limiting libraries. Okay, still going real quick. Anybody, how's chat looking? Chat looks empty, so I'm going to keep going. So the final things, and these are actually really important, are these are like Azure transliterations of Kubernetes configurations. So this is a API, this is a kubelet configuration parameter that determines how often nodes check in with the master, agent nodes check in with the master with standard sort of health heartbeat type information. The default for most recent versions of Kubernetes is 10 seconds. I think a long time ago it was 5 seconds, and it was increased to 10. So by setting this to 1 minute, what you're actually doing in practice is de-optimizing your Kubernetes clusters reconciliation loop, if that makes sense. So there's side effects of nodes checking in less frequently with the master, one of which is going to be reconciling where pods should be. So the master is responsible for doing that, and it's going to reschedule pods to what it determines an offline node is only after this threshold has been exceeded and the node hasn't checked in after that. So by setting this to 1 minute from 10 seconds, you are going to increase by 50 seconds, more or less, when those types of events occur. So it's definitely something to be aware of. Going through these three control manager configurations, this is related, and this is going to determine when a node actually goes to not ready. So this on the control manager says, in effect, if 5 of these intervals have passed, then I'm actually going to mark that node as not ready. This is a pod eviction timeout, referring to my first example. Off the top of my head, I'm not going to be able to explain it exactly, but it basically has to match all these values have to match reasonably to make sure that your reconciliation loop doesn't get into a permanent race condition where it never reconciles. So we've published some examples, and there's some other resources to look at for this kind of thing when you're tweaking these values. But the key is that when you engage backoff and when you engage rate limiting, that can get you part of the way there, especially in burst type events in a large cluster. For example, when you're deploying a cluster, that's going to result in a lot of traffic to the Azure APIs all at once. So by engaging backoff, what you're doing is you're really expecting that potentially some of those are going to fail, and you want to be in control of the knobs that determine how that retry enforcement is actually going to occur, so as to make sure that the requests don't all stack up on top of one another and you get tons of failures and tons of retries all in a small interval, which may put you into a ARM API throttling event that's very difficult to recover from. And the same is true of rate limiting. This is kind of like the last line of defense, where if your backoff configuration isn't doing what you think it's doing, or if it's actually not appropriate to increase these values so much, but you're still getting tons of QPS, you can tweak with these knobs to sort of have a last line of defense that literally limit how many QPS for these types of requests are going to the Azure API. So with all of that, in addition, by marrying that strategic enforcement with increasing the chattiness of your cluster with these configurations, what you can do is essentially find a balance of de-optimization that for real world usage doesn't affect cluster performance, but for burst events slows things down so that the Azure API is always happy.
We're running into time here, Jack.
Okay.
Sadly. Jason Hansen.
I'm happy to stop, and we can take this up in 2 weeks, and I can actually demo like building a large cluster. But yeah, Jason has a question. That QPS is enforced on the controller manager and each kubelet. That's exactly right. So this rate limit is basically an aggregate in common pipe that all of if you look at the PRs that went in place in Cloud they all go through this single enforcement pipe. So those requests have been cherry picked in the kubelet and on the controller manager, and all go through that common enforcement.
Yeah, but each component in the system has its own 3 QPS, not globally 3 QPS, right?
That's exactly right. So these are like runtime configurations. They're not like, there's no magic proxy or load balancer or anything like that. So these are per node configurations. So yeah, I think that's actually a good place to stop, because I could probably go on for 20 more minutes, and it sounds like that would be inappropriate.
Yeah.
So that's a sort of high level with detailed overview of how this configuration works. And I would be happy to demo in a couple weeks actually scaffolding a large cluster, or maybe like building it before the SIG starts, and then we can look around at the cluster and see what it looks like.
Okay. Cool. So that'll be part 1 this week and part 2 next. That's exciting.
Just one more thing, one question. Do you guys have an objection if we update your doc on large cluster with the equivalent configuration on the native processes for vanilla installation? For example, kubelet or kube control manager?
No, I would say generally we welcome all documentation. I mean, there may be some discussion in a PR, but please, if you have any documentation improvements, ideas, yeah, very welcome.
It's not ACS Engine specific. It's really just more for people deploying using vanilla, but at least they would have the equivalent. They don't have to go and search for all these configs to what do they need to turn on to have the same configuration apply on the cluster. But okay, thanks.
Great. Okay, so moving along. Thanks for the demo, Jack. That's great. So I wanted to point out works in progress. Right now, there's a link in there to a plan about Windows Server container stats. If we won't go through that necessarily in this meeting, but I would ask that if you could just take a look at that and give feedback if you feel that's appropriate. This is a really interesting proposal, and I think it looks good, so please do that. Below that, you'll see all the open PRs currently assigned to SIG Azure, and I also would request that people review those and help make sure that they're staying current. I would really like to set a norm for our SIG, if possible, in the future, where essentially at least one SIG meeting per month we go through and knock out, or at least try and knock out as many issues and PRs as possible, so that we're not introducing a lot of debt into each release cycle. I think that if every SIG did that and reviewed open PRs and made sure that they were rebased and that they had the LGTMs they need to proceed, or they reversed them out, that the entire Kubernetes ecosystem would be much happier for that. So let's set the example and have a really nice, clean backlog in our own group as much as possible. Below that, you will see PRs needing review and attention. The first one came through SIG Azure Slack channel, and this is somebody who's been doing a lot of work and a lot of questions and stuff in the channel. And they put up this pull request, and I just wanted people to take a look at it to be so it gets some attention. And I don't really have the chops to necessarily make a comment on it, but I would love for you all to take a look and make sure that it gets some attention, either a thumbs up or thumb down, so that we're not sitting on top of that code. And the remaining two. So is there anybody who's representing either of these? Any of the remaining pull requests that wants to speak to these or speak to what you need for help? All right, so that's a no on that. Please take a look at those at your leisure. In sort of backing up what I said moments ago about making sure that we look through our issues, right below is the next section is unanswered issues needing attention or review. These are issues that aren't getting traction. So in some cases, specific people in the community are called out as needing to contribute to these, or some they just need general help. I would request each of us to just take a quick peek at these asynchronously and add your 2 cents. And if you see somebody that you know could help resolve one of these issues, please do an @ and their name so that they can be mentioned and take a look at it, because we want to make sure that we're being good stewards of the community.
Just one thing.
Yeah.
I was waiting for my PR. You said 2 of them. You said a couple, so I was 2. So I was waiting for you to go to the next page.
Oh, okay. I didn't see you there, so please bring that up.
Yeah. So I'm bringing this up to the community because this is a request from customers that on AWS. So on AWS, the ELB, when it gets created, the load balancer, the code, what it does is that it creates a name out of the service, and the name is based on the UID of the service. So in other words, the name that is given to the ELB is a big, massive hash. So it gets very difficult for customers to find out which of their ELBs are being used for which service and for which Kubernetes clusters, because they just have a whole bunch of hashes on their ELBs. Now, they do have tags that define that, but just by looking at them, they have very bad names. So instead, what we are, the PR describes is a way for the user through annotations to ask the system to either generate a nice name using the service name and service namespace, or to use a name provided by the user in the annotation. And then that combined with a simple hash will make it simpler for the administrator to find out which of the ELBs in the cloud are being used for whatever Kubernetes cluster. So the thing is that code is not in the AWS section. That code is in cloud provider, which affects all providers. So I'm bringing it up here so that, and I'm going to every one of the SIG clouds also to bring it up so that everybody checks it out, make sure it doesn't break anything. It still follows the same rules as before. It starts with the first letter as GCE requires. It's only 32 characters, that's AWS requires. And those are the only restrictions that were there before. So those restrictions are still there. It's still backwards compatible, but those annotations, please make sure that it is compatible with the cloud provider.
Luis, thank you for bringing this up and raising awareness of this. I didn't actually know that this was underway, especially considering the providers are being broken out. Yeah. It seems like a really interesting anti-pattern to that work, actually.
Yeah, yeah. So whatever method that they want me to do it, I will complete it.
Okay.
I'm bringing it up.
Yeah, so we need somebody in this call right now who's watching you to volunteer to partner up on this from the Azure perspective. Does anybody here feel like stepping up and giving some eyes on this?
Going once. Everybody step back and leave somebody there.
Oh, Slack, you volunteered. That was
great. Totally.
Thank you so much for doing that. That was great.
I'll track it down.
All right. No, seriously. Are you seriously stepping forward?
Yeah, sure.
Okay. All right.
It's an issue of voluntold, but I'm down. I like the authority there.
Awesome. Thank you.
Cool. Thank you so much for that. Okay. So moving along, I think we've hit the unanswered issues. We're good there. So quick bit about release status. 1.8 is post-feature freeze. So there's some work, and I'm actually meeting with the people who are working on Windows RC3 coming up. But essentially, there's a certain amount of work that's going to be coming in for the Windows containers and whatnot, and also Windows networking. So you can have multiple pods connecting, or multiple containers in a pod connecting natively through the networking system in Windows. That work is being done, but that's not considered a feature, because basically the work that's going to be done for Windows nodes is considered parity work and not necessarily features. So just if you're interested in tracking that work, it's good to note that will be not in the features repo, but will actually be under PRs for parity. Code freeze for the 1.8 release is coming on September 1st. The actual 1.8 release time is going to be set to September 27th. And we're going to be hopefully cutting some alphas soon. So if you want to poke around with it, that'd be great. The challenge there is that in order to cut an alpha, all the test infrastructure, the blocking tests need to be green. And so far, that's an almost unobtainable state. So we are working on trying to do that. And part of that is coming from upgrade tests, which are notoriously nasty. So stay tuned. I'll let you know if there's an alpha coming out. So if you want to poke around with it, you can. 1.7.3 or 1.7.3 was out as of last week. Same with 1.6.8. We had an ACS Engine release of 0.5.0, And that is exciting for you to take a look at. There's a lot in there. So please, if you've been using ACS Engine for cluster provisioning, take a look and see what exciting things will come out of that release. Anybody here want to make any statements about the ACS Engine release?
It's awesome. It'll solve all your problems.
Cool.
RBAC.
It's good. Yeah.
Yeah. All right. And lastly, in our last 3 minutes, anybody have any announcements that they would like to give out?
I mean, it's more of a question. So once you have no more announcement, I just ask my question.
Sure, go for it. We've got 2 minutes and I've got a hard stop.
Any updates on the cloud provider separation? So we've seen in the PR, like this person on Slack, which made some changes in the Azure cloud provider. We know it's going to be branched out and work differently. So what's the status here? Can we still work on augmenting the cloud provider upstream, or there's a hard cutoff, a code freeze, we should stop? So what's the status on this migration?
Right now, I'm working on getting engineering resources within Microsoft to start coding out at least a alpha version of what the external cloud provider would look like. Right now, the cloud working group that's sort of overseeing that work from the procedure standpoint has not gotten very far. So I'm wondering if it's going to slip another release for a beta for that. So regardless, we're taking it very seriously, and we're going to be spinning up some engineering resources around it.
So we're still okay trying to push PRs in the upstream cloud provider?
Functionality that's not currently there, that's the current best way to do it.
Okay, thank you.
It's not encouraged, but it is necessary.
Awesome, thanks.
Yeah. All right, everybody. Thank you so much for your time, and I hope you have a great rest of your day, and we'll see you in 2 weeks.
Thanks, Jason.
Bye.
Bye.